welcome back to another STEM Helps video. We'll be doing Mr. Bigerton's Stoichiometry review, 1 through 8 odd. And before I start this video, I would like to preface that I'm assuming that you know how to simplify a reaction, meaning with its coefficients and matching both the number of molecules, number of atoms as well as its charge, and so I won't go into great detail about those. Alright, so lead reacts with hydrochloric acid in a single replacement reaction. How many moles of hydrochloric acid are needed to completely react with 0.36 moles of lead? Assume that the lead forms a +2 cation. Alright, so we have lead is going to go with HCl, and that is in turn going to go with lead 2 chloride plus, so that means there's 2 chlorides here, so H2. Alright, everything checks out. Alright, so the question asks how many moles of hydrochloric acid are needed. Alright, so you have 0.36 moles of lead, 0.36 moles of lead, and so 1 mole of lead, and here's the defining part of stoichiometry. You can look at the coefficients of this reaction and you can solve this. We're trying to find how many moles of hydrochloric acid are needed. So for 1 mole of lead, there's 2 moles of hydrochloric acid. So 2 moles of hydrochloric acid. And that's going to be equal to 0.72 moles of HCl. Alright, what is the mass of sodium chloride produced when chlorine gas reacts with 0.29 grams of sodium iodide? Alright, so we have chlorine gas. Sodium iodide, that's my fault. Oops. Sodium iodide. And that reacts with NaCl2, 2 plus plus I2. Alright, and so now this is a bit tricky. So you have 0.29 grams of sodium iodide, 0.29 grams of sodium iodide. The first step when you see grams here is convert to moles. Whenever in doubt, convert to moles, especially with stoichiometry. When you're going to have to make a single replacement reaction like this, you're going to have to convert this to moles. How are you going to do that? Periodic table. And so sodium plus iodide. So 22.990 over here plus iodine, which is over here. Alright, so you add up the number on the screen, and you're going to get a total of 149.89 grams of NaI for every 1 mole of NaI, or sodium iodide. Alright, and now we can use stoichiometry. 2 moles of sodium iodide, is equal to 2 moles of sodium chloride. 2 moles of sodium chloride. Why did I do that? Well, because we're trying to find sodium chloride and we're given sodium iodide. And look, what's the mass of sodium chloride? And I'm assuming they're asking in terms of grams. And so we have to go back to the periodic table. Here, let me write the step first. 1 mole of sodium chloride is equal to so many grams of sodium chloride. Alright, and to find the number of grams, you go up to the periodic table again. Alright, we got sodium and we got chlorine. And so you add these two numbers up and you will get a total of 58.44. So 58.44. And now what you're going to do is you're going to take that number and divide by 149.89 and also multiply by 0.29. I know it's a bit of a crazy problem, but alright, I'm just plugging into my calculator and I got an answer of 0.11. Now let's say if it didn't make sense to you. Just like intuitively, does this make sense? Alright, these 2 moles kind of cancel out here. Really, you don't need to punch this in your calculator. It would be kind of redundant. So 58.44 plus 149. So this is around 150. This is around 50, so it's a third. So 30% of a third is around 0.1-ish. And that does seem to be what I got in my calculator. So 0.11, don't forget significant figures, grams of sodium chloride. Alright, next problem. How many moles of sodium bromide will be produced when 0.69 moles of bromine gas reacts with sodium iodide? Alright, so we have bromine gas, Br2, plus sodium iodide will release bromine, or sorry, that's my fault. Sodium bromide plus iodine gas, and then you just put this 2 here and okay, so if you have 0.69 moles, 0.69, oh sorry, that's my fault, 0.69 moles of bromine gas, 1 mole of bromine gas is equal to 1 mole of bromine gas is equal to how many moles of sodium bromide? Well, we have 2 moles of sodium bromide here. 2 moles of sodium bromide. And so we're essentially multiplying this by 2, and so that's going to be 3.8 moles. I made a fatal flaw. Now, I want you to pause this video and see what mistake I made. If you found this, congratulations. You'll do very well, at least with significant figures, and not get points off. 0.69 moles has 2 significant figures, so my answer should be 1.4. My answer should be 1.4 moles. I'm glad I stopped myself before I wrote down the wrong answer. 1.4 moles of sodium bromide. Okay. And final one. Phosphorus will react with bromine to produce phosphorus tribromide. Alright, covalent compound in the synthesis reaction. How many grams of phosphorus tribromide will produce if 0.78 moles of bromine is reacted? Alright, so we have phosphorus plus bromine is going to be phosphorus tribromine and that would only lead to this. It means phosphorus has a positive 3. Usually has a positive 5, but now it has a positive 3. That's fine by me. Okay, so how many grams, ooh, this is very important, grams of phosphorus tribromide will be produced if 0.78 moles of bromine was reacted? Alright, so we have 0.78 moles of bromine. We're trying to go to phosphorus tribromide. So, for every 3 moles of bromine, we have 1 mole of phosphorus tribromide. And we're not done yet. We need to multiply 1 mole of phosphorus tribromide by the number of grams phosphorus tribromide weighs. So PBr3 going all the way up to the periodic table. Alright, so phosphorus is here. Oops, I made too big of a circle. Phosphorus is here, and bromine is here. Here, I need to make the circle bigger so you can actually see the numbers. Okay, so phosphorus tribromide, make sure that, don't make this mistake, make sure you multiply 79.904 by 3, because there's 3 bromines. So you add by 30.974, and I got 270. All right, so I got 270.67, 270.67, and so now to find the answer we are looking for, we're going to equal this number of grams of phosphorus tribromide. So we multiply just straight across. So multiply by 0.78 and divide by 3. And I got 70.37. Again, let's not make the same mistake as before. There's 2 significant figures here, so therefore my answer is just 70 point. Now you might be wondering, why did I put the point there? Well, if you were to get rid of the point, let me make this eraser smaller. If you get rid of the point, what's going to happen? Your teacher's going to think, well, this kid doesn't really know what he's doing. He just put down 1 significant figure, which is wrong. You know exactly what you're doing. That's why you said, I have 2 significant figures. And I hope that's helpful.